Okay, I wanted to provide a video for some of these extra practice questions. And these are on page 40 of your assignment booklet. I had assigned some of these just to help you prepare for your exam on Friday. So if we look at the first question, so of course you could do all of them, but I'm going to provide videos for the 1, 2, 4, 5, and 6. If we look at the very first question, it says a company makes motorcycles and bicycles. In any given week, a total of up to 500 vehicles can be made. Draw a graph showing the number of motorcycles and bicycles that can be made in 1 week. Also provide the corresponding linear inequality in 2 variables. So a company makes motorcycles and bicycles. In any given week, a total of up to 500 vehicles can be made. So motorcycles and bicycles combined are both called vehicles. Okay, and a total of up to 500 vehicles. Up to, that means the maximum would be 500. So that's less than or equal to 500. Okay, and if we wanted to define a variable here, we could say let x equal the number of motorcycles and let y equal the number of bicycles. And so of course, I think that if we made x number of motorcycles plus y number of bicycles, those combined must be less than or equal to 500. So there would be our linear inequality. And if we wanted to draw this, okay, there's a couple of ways we could draw this if we wanted to think this through. Once we have our equation, we know that to draw a graph in, we could think of this in a couple of ways. I could think of this in y equals mx plus b form. So I could think of this as y equals, or y is less than or equal to, let's say, negative x plus 500. Let's keep that inequality sign for now. Another way of thinking about how to graph this would be to find my x and y intercepts. If I wanted my x-intercept of the corresponding function, we would let y equal to 0. And if y is equal to 0, then we would have x plus 0 is equal to 500. So I'm just looking at the line, the linear equation, not the inequality. So x would be 500. If we wanted to find the y-intercept, then x would be equal to 0. And so, of course, 0 plus y equals 500. So y equals 500. So what that basically means, if we think about it, is if we've got a graph, and I'm going to put bicycles on the y-axis, okay, bicycles on the y-axis, so I would just label that, and motorcycles on the x-axis. Of course, this is bicycles versus motorcycles. If we decide, or if this company decides to make all bicycles 1 week, if they can make a total of up to 500, they would make 0 motorcycles and 500 bicycles. So that was our y-intercept. Or alternatively, they could decide to make 500 motorcycles and 0 bicycles. And so if we graph that, there would be our line, okay? Now, of course, this is an inequality and I haven't shaded yet. Another way to have graphed this could have been to graph the equation. Just when we think about the equation itself of that line, it would be y is equal to negative x plus 500. So if I think of my starting point at my y-intercept of 500, if we go down 500 and right 500 over 500, negative would be a -1 slope. So there's our -1 slope right there when I think about it on the graph. So let me just erase those little counting points. And so of course we would shade underneath, and we know there's sort of some inherent restrictions here, right? One of the inherent restrictions is that the company, we presume, cannot make negative bicycles or negative motorcycles. I guess we could get technical and say they're taking them apart, some of the ones from that they've already made, but we're just going to pretend that they can't make negative amounts of bicycles and they can't make negative amounts of motorcycles. So there would be our graph for the first question, and there was our equation, or inequality rather, for number 1. Okay, for this next question, what I've done is I've just created a graph just to save us some time here. And it says that Fiona plans to start a fitness program which requires that she jog and do calisthenics up to a maximum of 10 hours each week. So up to a maximum, so that's less than or equal to, okay, that would mean she wants to spend less than or equal to 10 hours per week, okay, a maximum. She must spend at least twice as much time jogging as she does doing calisthenics. And it says draw a graph showing the amount of time she can give to each activity. Also provide the corresponding linear inequality in two variables. So there's actually two linear inequalities here. So the corresponding linear inequalities in two variables. So the one is very similar to the bicycles and the motorcycles up above, right? Fiona in the first question, in the first sort of part of the question, it says she can jog and do calisthenics up to 10 hours per week. So if she decides to, do calisthenics for the entire 10 hours, then she would spend no time jogging and 10 hours doing calisthenics. If she decides to do 10 hours of jogging, she would do no hours of calisthenics. So there our inequality would look something like that. Okay, and the inequality itself, the equation would be x. I guess if we say jogging is x and calisthenics is y. Okay, we probably should define those variables, so let's write those down. Let x equal jogging time, and let y equal calisthenics time. So we would say that x plus y is less than or equal to 10. And of course we would shade below there. But before I do any shading, I guess we could shade there in a light blue here. Okay, so there is her constraint there, that she has a maximum of 10 hours per week. But now there's another sort of constraint on her workout time. It looks like it says that she must spend at least twice as much time jogging as she does doing calisthenics. So what does that really mean? So sometimes it's difficult to come up with this second kind of equation. So what I want to do is just put a couple of numbers to it. So if we had jogging and calisthenics, and let's just pretend, now of course we have no idea exactly how much time is being spent, but she must spend at least twice as much time jogging as she does doing calisthenics. So if jogging is our x here and calisthenics is our y, so let's just put a number. Let's just pretend she's going to spend 3 hours in a week doing calisthenics. And her jogging would therefore have to be twice as much, which would be 6. So if I put numbers to this, it's probably kind of obvious then that we would get x, right? Her jogging amount of time would be equal to 3y there, if that was an equation. But of course, this is an inequality. She must spend at least twice as much time jogging as she does doing calisthenics. So x must be greater than or equal to, oh, I think I wrote 3y. I meant to say 2y. Okay, she needs twice as much time there. Okay, I wrote down the 3. So x is greater than or equal to 2y. Now, how to draw that? Okay, how to draw that? If I think about this as a y equals mx plus b sort of situation, I would divide both sides by 2, right? And if we're dividing both sides by 2, then we would get y is less than or equal to 1/2 x. If I read this from the y, okay, remember, if I read this from the y, I'm going to switch this around. Remember, if we have 2 is less than 5, and I write that around, I would write the 5 there and the 2 there. I would have to flip that sign. So same thing goes with our equation, our inequality here. Y is less than or equal to 1/2 x. So of course, when I think of that as y equals 1 mx plus b, our b value is 0. So I would start here at my origin, And it's a little bit tricky to go up 1 and over 1 because we don't have a grid. But I know if we go up 10 and over, up 5 and over 10, that's kind of an equivalent to 1/2, right? 5 over 10 is the same as a slope of 1/2. So I'm just going to eyeball it. And then of course, this would be the inequality there, okay, which really would go indefinitely, but so now she's got 2 constraints. She's got a maximum of 10 hours that she can spend, okay? Anything along this line right here that I'm kind of overlapping there, anything along this line would mean her time spent is equal to 10 hours exactly. Anything less would be a combination of times that it would be less than 10 hours, okay, fewer than 10 hours. And if y is less than or equal to 1/2 x plus b, and our b value there was 0, okay, she's also got this extra constraint that her jogging must be twice as much as her calisthenics. So the solution region would be the overlap here, which would actually be this part right here. So now this is a tricky question. I doubt I would really expect you to be able to do this on an exam, but for understanding and teaching purposes, probably doesn't hurt to understand. And this is a rare one where we end up with 2 inequalities and sort of an overlap. So it looks like she would be able to, you know, jog and do calisthenics in any of these particular, any of this region. And of course, anything along the lower line here would mean she's spending a total of 10 hours. Anything in here would mean she's still jogging twice as much as she is performing calisthenics, but it would be less than 10 hours. So hopefully that makes sense. All right, for this next question, I'd like to just draw a quick sort of sketch here. It says the leg of a right triangle, one leg of a right triangle is 3 centimeters longer than the other leg. If the area, and it's a right triangle, so I'm going to make sure I draw my right angle. If the area of the triangle must be greater than or equal to 14, so the area must be greater than or equal to 14 square centimeters, algebraically determine the range of possible lengths for the shorter leg. So in other classes I've sort of mentioned, one rule of thumb is sort of to make the variable the thing we know nothing about. One leg of a triangle is 3 centimeters longer than the other leg. So the one we know nothing about is the other leg. Okay, so this would be our x, or our length. We could call it length, or we could call it x. That's x length. The other one is 3 centimeters longer than x. And so algebraically determine the range of possible lengths for the shorter leg. So what I need to do is our area needs to be greater than or equal to 14. So I need to remember quickly the area formula for a triangle, which is base times height divided by 2. Okay, there's that triangle area formula. And so if my base times my height divided by 2 must be greater than or equal to 14, I'm going to plug in those values. So the base of this triangle, right, we know we can't have base and height. We need one variable. So we've got the x and the x plus 3. So x times x plus 3, all divided by 2, must be greater than or equal to 14. Then right away I notice I've got a fraction. Well, that's not cool. So how do we get rid of that fraction? We want to multiply both sides by 2. And the 2's on the left-hand side will, of course, cancel. And we've got our x squared plus 3x is greater than or equal to 28. And let's move that 28 over. We know we can't factor until everything is equal to 0. And so from there, let's factor x squared plus 3x minus 28. I'm going to factor the corresponding equation. And we get x plus 7 times x minus 4 is equal to 0. So x would be equal to negative 7 and x would be equal to 4. So this is a quadratic, and if I just sort of do a quick sketch of this, Okay, here would be my negative 7, and here would be our 4. And so if we graph the inequality, which is x squared plus 3x minus 28 is greater than or equal to 0, where is this graph above the x-axis is basically what we're being asked. And so it is above the x-axis when x is greater than or equal to 4, or x is less than or equal to negative 7. So of course, if we think about this, we know that we cannot have a length of negative 7 or negative anything. So our answer is x is greater than or equal to 4. This other answer is an extraneous root. The only reason it's extraneous is because this is a situation. Okay? So normally that would be for sure an answer to that question if it didn't have the restriction that length has to be positive. Okay? The inherent restriction there. Okay, hopefully that one helps. Okay, so let's take a look at this next one. It says the length of a rectangle is 2 centimeters less than 3 times the width. So I'm going to start with drawing just a little rectangle here. Okay, because we're talking about a rectangle, let's draw one. Doesn't help, doesn't hurt, I mean. It always helps to kind of have a little bit of a diagram. So there's a rectangle. And it says the area of the rectangle must be less than or equal, less than 8 square centimeters. So the maximum area would be 8 square centimeters. Algebraically determine the range of possible widths. So the length of a rectangle is 2 centimeters less than 3 times the width. So the thing that we know nothing about is we really know nothing about the width. So I'm going to identify that as my basic variable w. And our length we can define as L. But we also know that the length is defined as 2 less than 3 times the width. So whatever our width is multiplied by 3, subtract 2. And now we're looking at those in terms of area. So area is length times width. And in this case, our area is our width times 3w minus 2, or 3w minus 2 times w. We could write that, I guess we could write that in the order, right? Our length itself is 3w minus 2 times our width. Okay? Okay, so we can expand that right-hand side, and we know our area would be 3w squared minus 2w, but we're also told that 3w squared minus 2w, our area must be less than 8. So if we rewrite that as a single quadratic on one side, move everything to one side, then we get 3w squared minus 2w minus 8. And if I think about the corresponding equation and want to solve that, now keep in mind this is equal to 0, or we've got a 0, we have one variable. So we're looking at for what x values, in this case w, for what x values is this quadratic function below the x-axis. We're not looking at the shading for this one. So let's find the corresponding roots to this equation. And to do that, we would say we want to know, we're going to have to factor this using decomposition. So we're going to look at our product of negative 24 with the sum of negative 2, and that would be negative 6 and 4. So I'm going to rewrite this as negative 6w, that should be squared, plus 4w minus 8 is equal to 0. I'm looking at the corresponding equation. So we can factor out the 3w, and we would get a w minus 2. We can take out the 4, and we get a w minus 2. And so 3w plus 4 times w minus 2 is equal to 0. So the obvious factor here is the w is equal to positive 2. The other one that may not be quite as obvious, if I just go over here and do this work, we get 3w plus 4 is equal to 0. So we want to take and move over that w. And if we move over the 4 rather, the negative 4 becomes, positive 4 becomes negative 4. Oh boy. And then we divide both sides by 3. And then we end up with w is equal to negative 4 thirds. So that's our other root. And some of you might be able to start sort of seen that. We move over the 4, becomes negative, and we divide by the 3. So some of you might be able to see that in one step. So then if I sort of do a really bad, not so important that it is very nice, sketch, we have our negative 4/3 and our 2. And so we want our area to be greater than, less than 0. And so because our parabola opens up, it faces up due to the fact that our a value is positive, it's sort of something like this, isn't it? And so if we want that area to be less than 8, right? In this case, we are looking for the values for which the graph is underneath the x-axis. Now, there's sort of an inherent, we know that our w, there's an inherent restriction here that our width has to be positive, right? Our width would have to be greater than or equal, well, greater than 0. It couldn't be equal to 0, because if it was equal to 0, then we would have no width at all, which would mean we'd have a straight line and it wouldn't be a rectangle. So we know, therefore, that sort of normally, okay, on a regular question, okay, if this was regularly, we would have the restriction, and we would say that x would be between negative 4/3 and 2, but in this case, x has to be between 0 and 2, okay? Has to be greater than 0 and less than 2. Now I noticed the answer in the back, okay, the answer in the back actually says x must be greater than 2. Okay, if we look at this question here, x, or our width rather, right, our width must be greater than 2, but that's actually incorrect. It has to be between 0 and 2. And I can show you, if we say that width would be greater than 2, unless I've made a mistake here somewhere, which I don't think I have, then if our width was in fact greater than 2 and we were to sub in a value there, okay, this has got to be our answer. Our width has to be between 0 and 2, because if our width was somewhere greater than 2, and if we tested that, okay, let's test a point like width of 3. And if we test a point of 3, then our width would be 3. Our length would be 3 times 3 minus 2. Okay, and so 3 times, right? I'm going to put a bracket around there. That would be 3 times 3 would be 27 minus 2, which would be 25. And therefore our area would be 75 centimeters squared. But we want that area to be less than 8. So let's test something between 0 and 2, such as a width of 1. That's a nice whole number. And we would get an area, I guess we should say area here. Our area would be our width of 1 times 3 times 1 minus 2, which would be 1 times 1, which would give us an area of 1 square centimeter. And again, if we were to pick something a little bit bigger, so like maybe a width of, 1.5, and we plug that in, we would have an area of 1.5 times, let me squeeze this in somewhere. I'm just trying to sort of show you that the answer in the back is wrong. Okay, if we said let the width be 1.5, then our area would be 1.5 times 3 times 1.5 minus 2. And if we just plug that in our calculator, 3 times 1.5, okay, that's 1.5, and then 3 times 1.5, I believe that's 4.5, isn't it? I think so. 3 times 1.5, yeah, that's 4.5. Subtract 2 gives us 2.5, and 2.5 times 1.5 gives us 3.75. So anything between 0 and 2 will give us an area less than 8, as long as our width is between 0 and 2. So keep that in mind for that question. All right, let's take a look at this next question. It says, suppose a rectangular area of land is to be enclosed by 1,000 meters of fencing. And so if we've got this rectangular area of land, and it says the area is to be greater than 60,000 square meters, what is the range of possible widths of the rectangle? So we have this little bit of information here that basically the perimeter, okay, is going to be 1,000. So we've got 2 length plus 2 width is equal to 1,000. So we know that our length and our width and another length and another width would have to total 1,000 meters of fencing. I can simplify that by dividing everything through by 2. And I would get a length plus a width would be equal to 500. Now, so that's our perimeter. I'm using perimeter. And now it also says suppose the rectangular area of the land, okay? The area is to be greater than 60,000. So our area must be greater than 60,000. And so our area is our length times our width. And that must be greater than 60,000. So that's all fine and dandy, but I know I can't have 2 variables here. So I've got a length and a width. One of those I need to replace with another. So it doesn't really matter which one, but I'm just going to randomly choose to isolate my length here. And so when I move my width over, it becomes a subtract W. So now I've got a length is 500 minus W. Okay, we could have used 2 lengths is 1,000 minus 2 W's, and then we would have divided and simplified. So our length is 500 minus W. Right, that makes sense. Whatever this, so hopefully that makes sense. We know that this length plus this width must equal 500, right? Because that's half the fencing. So whatever our length is, okay, whatever our width is, we subtract that width from 500, we'll get our length, right? If I told you length and width, that's half of our fencing. If I said the width is 100, for example, then our length would be 500 minus 100, which would be 400. So I hope that kind of makes sense, where those numbers are coming from. So I'm just making up the 500 and the 100 for now, or the 100 I should say, but just as an example, okay? For example, okay, if the width was 100. So now let's plug this in for our length. And so now we've got 500 minus W times W must be greater than 60,000. And so when we expand this out, we get a negative W squared plus 500 W minus 60,000 is greater than 0. So we're looking at a parabola with a negative A value that is above. We're looking at where it is above the x-axis, where it's greater than 0. Okay, so in order to solve the corresponding equation, those are pretty big numbers. I could put those in my graphing calculator if I wanted, or what I noticed right away is I noticed that the product would be a positive 60,000. I'm looking at a sum of 500, so those numbers would be 200 and 300. Okay, so we could factor out our negative here, which would give us a positive W squared minus 500W plus 60,000. And so we get W minus 200, W minus 300. So W would be 200 and W would be 300. Okay, so let's just do a quick sketch, nothing fancy whatsoever. Okay, we know that this is a negative opening, downward opening parabola because the A value was negative. And so it's something like this, where one of our roots was 200 and one of our roots was 300. Okay, we would go back to that original equation, the original inequality, because of course we just simply factored out the negative A value to find the roots, but we're still looking back at the negative. inequality. And so this question here says, where does this negative inequality, where is it above zero? Well, it's above zero between 200 and 300. So in fact, that would be the answer. We would say our W value would be between 200 and 300. And these are sort of like open dots there. Of course, I should have done the open dots to begin with, but because we've got the greater than 60,000 not equal to. So there would be the solution to that particular equation. Hopefully that helps. You're welcome to do more, but hopefully those videos help for any of those questions you've decided to try. Okay, good luck, and don't hesitate to contact me in case you have any questions or concerns.